We'll go ahead and get started while some people are still filing in. This is the deep dive on Amazon Kinesis. We did swap the sessions today. DynamoDB will follow directly after this one. Apologies for that change. And my name is Ian Myers. I'm a solution architect working with customers around Europe on big data platforms. Based in the UK and very pleased to be able to join you guys today. So we're going to talk about Kinesis, which is Amazon's big data streaming platform designed to facilitate doing real-time processing of data at any scale. The fundamental premise of Kinesis is that you need to decrease the amount of time between when an event happens and when you can analyze it. And so we're able to use Kinesis as a way of moving data around. We can use it as a publish-subscribe messaging mechanism, and we can use it as an application eventing framework. It's designed to be very low cost, very easy to use, and extremely elastic to work with your data volumes, whether they're very, very small or in the terabytes per hour. It's also designed to give you very, very simple and widespread access to clients to process the data or to push data into Kinesis directly. The architecture of Kinesis is, as you see on the left, as many data sources and as many different types of data as you might want to push into your infrastructure. These data sources can be absolutely any type that you require. Kinesis is a binary-based system, doesn't have any notion of what the data is that sits on the stream, and so you can really use the format that makes most sense for your application. We see customers use JSON data, XML, protocol buffers, Thrift, whatever you may find works best for your application. And that data is pushed into a Kinesis stream, which is a regional resource that is extremely highly durable. The implementation of that stream is through a set of what we call shards. And a shard is the unit of capacity that allows you to grow and shrink this stream elastically. And then on the back end, we have our applications, which are consuming this data from a stream. And unlike a queuing mechanism, Kinesis is designed to support as many applications as you require. Each application can consume the same stream, can get the same amount of data, but will not be at exactly the same point in the stream at any one time. They can go back to the beginning of the stream and read data from the beginning. They can do whatever they want independently against the very same data set. And the stream is offering a 24-hour retention period of your data at any scale. So we would use Kinesis to build, for example, a metering architecture, where we push in data files or data streams that include metering data, for example. That would go into Kinesis and be available for 24 hours for processing by a set of Kinesis-enabled applications that might do things like auditing our metering records, or be doing incremental bill calculations, or providing an API to read that data. One of those applications would be storing our stream in whatever format makes the most sense for you into a platform like S3 so that we can access that data with a variety of other tools, including tools like Elastic MapReduce or Amazon Redshift. And we'll talk about some of the ways that we make that very, very simple to manage. So the core components of Kinesis that you should consider, first is the stream. It's a named resource that you can use to create a security policy around a type of data. Some customers will have one stream for their entire business. Other customers may create a separate stream for every discrete data type that they want to move around in their business. And either is completely fine. You can decide which of those strategies, or a mix of those, most correctly represents your application data. And then these shards are the real workhorse that do the work for us. And a shard is always present. There's at least one shard in a stream. And you can add and remove shards from your stream to give yourself more or less capacity as required. Each shard will run at 1 megasecond or 1,000 writes per second. And then you can read the data back out of that shard at twice that speed, 2,000 reads a second or 2 meg. And you can add shards to give yourself whatever throughput you require. And we have customers running at many terabytes per hour by adding lots of shards to their stream. The shards store that data in a highly durable fashion across multiple availability zones in a region. And so a put into your stream is as durable as putting it into, for example, DynamoDB. And this can enable some really powerful new application use cases. For example, where previously you've managed files on your application instances and needed to worry about disk space and so on, we can now stream through those files in real time on the applications and move every log line into Kinesis. That single event is now multi-AZ durable. We can throw the file away because we can reconstitute it on the back end. When you write data into Kinesis, you supply what's called a partition key. Partition key is defined by you, and it allows us to route your data to a shard. Kinesis offers you a very important characteristic of a stream that not many other platforms can offer, and that is perfectly ordered delivery of data to your consumers in the order that they were put in by the producers on the basis of the partition key. So what would a partition key be? Well, it's usually very obvious from your application what kind of partition key you would use. It might be the session on a web application, or it might be the user ID. And the contract that you get from using Kinesis is that you will be able to consume the data in exactly the order that you put it on, at any scale, across multiple availability zones. And that gives us some really powerful primitives for building things like behavioral analytics, where we want to be able to track what happened over a sequence of time. You can have as many partition keys as you want, and they generally follow the same best practices as you would find for a Redshift distribution key or a hash key in DynamoDB. We want a large number of discrete values, and we want them to be uniformly distributed over the range of all possible input values. And then lastly, there's a concept of a sequence number. When you push data into Kinesis, it will give you back a sequence number that allows you to uniquely identify that record on the stream and allows you to agree the effective Kinesis identity for a record between the producer and a consumer. The sequence number is guaranteed to be unique, and again, can be used at any scale for things like deduplication, which we're going to talk about. So let's talk about getting data into Kinesis. So you have the ability to push data from a variety of different sources, and we call these producers. Producers use a put or a put records, which is a batch interface, to push data into a stream. The shard is automatically selected, and we give you back a sequence number for that write. The partition key is analyzed in the call and used to route the request to the correct partition key. If you don't care about the order that the data comes back off of Kinesis, then you can just use a big random number. Easy enough. So when we're pushing this data in, we can have as many producers as we require, and we can support whatever ingest rate is required by adding shards. So it is entirely possible to build a mobile application that uses the AWS SDK to push data directly off the mobile into Kinesis. And we're very happy to take millions of producers. There's no limit on how many producers we can have pushing data in. Apologies for that. And the other thing I want to highlight is the fact that an individual event can now be up to 1 megabyte in size. Up until about 2 weeks ago, they were 50K. But it's one of the things we really heard from customers that they needed a much larger event. We're going to talk about how to use that additional capacity a little bit later. We also added something new, which is the Kinesis producer library. The producer library is a brand new module that gives you a way of asynchronously producing data for Kinesis so that you can run at virtually any scale within your application, and the write latency to Kinesis will not affect your application performance. It's designed to run as an async daemon that sits alongside your producer codebase, and certainly is intended for the application server sort of producer. And one of the features that the KPL offers you is a feature called aggregation. Aggregation allows us to take better advantage of this 1 megabyte payload size by automatically concatenating together messages onto a stream. And we're going to see how this can be used to get a massive cost savings. The data itself is protocol buffers when you use Kinesis producer library aggregation. And we effectively buffer all of that data in memory and then concatenate it onto a much more compact stream. So we can take better use of the 1 megabyte events. The other thing that the KPL does for you is it allows you to write to multiple streams concurrently. So you can have a single event being fanned out, and you don't actually need to worry about individual streams. You simply indicate the stream name when you do a write, and the KPL sorts out all the routing for you. Other ways people get data in is what you would absolutely expect. Apache Flume, for working with log files, you can create a Kinesis channel, and the data will be automatically pushed to Kinesis. You can use FluentD for the same use case. And then, of course, the most commonly used logging frameworks of Log4j, Apache Commons Logging, and Log4net all have appenders that are available. And this is a really nice way of taking an existing application that's generating log events that you need to analyze and simply being able to move away from files and move to streams. The log management framework itself is doing all of the hard work of pushing the data onto Kinesis. And then we can consume that and reconstitute the files at the stage of getting the data back out. At the core of consumer applications, we have the Kinesis client library. Again, like the KPL, it's a library that you will include in your code, and it has a variety of different features for different customers' requirements. The first version we did was in Java, and then we quickly added support for Node.js, for Ruby, and then we did the multi-lang KCL. And the idea of the multi-language environment is that we can never keep up with all the possible languages that our customers want to use. So instead, let's make working with Kinesis streamed data extremely pluggable. So you can run the multi-language daemon, and it has specific bindings and examples for Python, but you can actually plug in anything you want. You could use bash, you could use shell commands of any type to process your data. You could use COBOL if you want. And the KCL gives us some really important capabilities to consume the data in that it does automatic state management and tracking of where our application has gotten to in the stream. What you'll get is a very simplified model for working with streaming data in that you build your application in such a way that you're completely abstracted from thinking about the distributed nature of Kinesis. Instead, with the KCL, a worker thread is created for each of the shards that you're consuming data from. And that thread conforms to an interface that gets pushed a block of data every time there's something to consume from the stream. So when we build applications with KCL, we're actually having all the data pushed to us, and all we have to do is implement the logic to process that data and then say, yep, I'm happy with that, checkpoint, and the application will move forward. It also takes all the responsibility for dealing with the elastic nature of Kinesis by adding and removing these worker threads every time the topology of our stream changes. Every time we add new shards or remove shards, the KCL will take responsibility for making sure that an application executor is working against that data. And then there's a simple semantic. Checkpoint allows your application to say, I'm happy with where I've gotten to, now let me get some more data. If you don't checkpoint, you'll be given the same block of data back again, and so you can very easily retry operations that might have failed. The other thing the KCL does for us is it babysits our application. It will restart workers if they fail for some reason. And so when we build applications with KCL, we really get this very, very simple way of interacting with a huge distributed system, and where we don't have to solve any distributed system problems ourselves. So we built a lot of nice things with that KCL that we can share with you, like Kinesis connectors. These are components which are given to you on GitHub, open source code, and for instance, you have an automatic archiver to S3. This will just store your stream for posterity in S3, and it's extremely good pattern to store your data in its most raw event source format that you can. You can then use the Redshift connector to subsequently load data directly into Redshift. It's a simple configuration where you describe the format of your data, whether it's JSON data or CSV, and then the connector will just automatically load that data after it's been made persistent to S3. There's also a batch appender for DynamoDB and an automatic indexing component for Elasticsearch. And these can all run at exactly the same time on a single stream. You just have to spin them up and run them. And you can extend them to build complex transformation pipelines. The core of the connectors application is, at first, the transformer. A transformer allows you to go from the format of the data that sits on the stream to some other format that you want to emit. You then have filtration capability, so you can say I'm only interested in events of a certain type, or you can do some sort of cleansing that says, actually, we think these aren't records that we want to keep. You then have a buffer. The buffer could be memory-based, it could be disk-based, you could buffer into a database. And then lastly, you have an emitter. And an emitter will write the data to S3, it will subsequently load into Redshift, and there are a lot of interesting implementations of emitters out in the wild for talking to Elasticache or MongoDB, you name it. We can also consume data with Storm. We supply you with a spout for Kinesis, so you can push data into your Storm topologies from Kinesis. And of course, Apache Spark. There's native support within Spark streaming for Kinesis as a data source. You create a D stream, a dynamic stream for each shard, and then the Spark receiver component will automatically commit records that have been persisted into an RDD and processed by your application. And this is a great opportunity for me to shamelessly plug the fact that we just launched support for Spark natively within Elastic MapReduce. So it's never been easier to run Spark on AWS. You also get some really important features of Elastic MapReduce that you weren't able to leverage very easily before. For example, the EMR file system, which is an overlay on top of HDFS that gives you massively improved performance for your Spark jobs when they're working with S3-based data. And of course, we have AWS Lambda, which is able to act as a receiver of data from Kinesis. It's one of the native event sources that Kinesis supports. We have a stateless JavaScript or Java-based piece of logic that you compile with all of its dependencies and then deploy within AWS Lambda. You create the Kinesis stream as the event source for that function, and then you just allow us to host that logic, scale it up and down elastically, and only pay for the actual invocations that you make. So you're able to have a completely managed stream infrastructure with Kinesis and a completely managed and serverless compute infrastructure to receive that data. The AWS SDK is built in to Lambda. All you have to do is provide the logic, how much RAM it requires, and how long you want to allow an individual function to run. And then we automatically use a KCL, an embedded KCL within Lambda, to push data out of the shard and into your Lambda function. There's also some really nice community libraries for writing Lambda functions in Python and in Go. And we do give you access to the underlying file system that sits within the Lambda container so that you can do interesting buffering and so on. And of course, Lambda functions can call each other. So you can start to build a very powerful event-driven architecture with Kinesis as the event handling mechanism and Lambda as the processor for that data. Lambda functions might be creating new Kinesis streams. And so your entire application can be built with Kinesis for streaming, Lambda for compute, and probably DynamoDB for long-term storage. And that would be a completely serverless architecture, which is extremely powerful. So why would you use Kinesis versus doing this yourself? Well, let's keep in mind that durability of these events is of paramount importance. These are what happened on your application, and so they represent the most important data source that you can use to understand your application. Kinesis writes every single event synchronously to multiple availability zones, and you don't have to do any ops. You just provision the stream and get on with the business logic. If we contrast that with building this yourself, you're going to have to consider whether the application is staging that event data only in memory, how often it syncs to disk. You're going to have to configure replication yourself. And ultimately, your recovery point is whatever the replication lag is between two separate machines, which is a very different prospect for durability than the out-of-the-box delivery to multiple AZs with no operations. Also, from a performance perspective, when we launched Kinesis, it had what we call TP99, or 99.9% of events, TP99 latency of between 3 to 4 seconds. We've now shrunk that down to below 1 second. And TP50 is around 50 milliseconds. So you're able to build systems that have low latency requirements off the back of an infrastructure that will scale to virtually any size. If you do this yourself, things like the scale and the latency is going to be based upon CPU. It's going to be based upon storage. And you also have to consider what happens if your cluster is interrupted for some reason. Whereas, because Kinesis is a regional service, we don't need to worry about the interruption. And in fact, we can lose AZs within Kinesis, and you'll never know that it happened. From an availability perspective, you also have to consider how do you build a topology that will give us the availability and durability characteristics that you require for this essential data. Many systems that run multiple brokers actually have a database underneath them that requires quorum in order to be up. So if you build that on multiple availability zones, if they can't talk to each other for a short period of time, you may not be able to write to this infrastructure. And now we've got millions of producers who are unable to push their data in, which is really, really not what we want. Your availability then becomes either only as good as a single availability zone or as good as the interconnect between them. Whereas with Kinesis, because we're always implementing 3 separate storage facilities, we can survive an AZ lost without any interruption of service. Also, from an ops perspective, you have to consider the fact that with Kinesis, you provision the stream, and if you want to add and remove capacity, it's a single request. Whereas when you roll this yourself, you have to build the instance, install the software and configure it. You have to think about managing disk space and compaction. You have to manage the replication yourself. And it's a very big job. The other thing that we tend to see is that when you build these yourself, if you want to scale up and down beyond the capacity that you planned up front, you often have to migrate to a totally new infrastructure that increases, for example, the partition count. And that can be very onerous on your application. It can mean new application installations completely. And we can really deal with any type of elastic response of our applications with Kinesis, scaling up and down dynamically based upon what you're pushing in. We can maintain a fleet that's very, very small during quiet times and then scale up in the day. And keep in mind, when we use the KCL to process that data, because we're automatically getting a thread provisioned for each shard, our application fleet on the back end is going to scale up and down accordingly. When you build this yourself, you do have to do quite a lot of planning up front, and you have to choose a partition count that's going to allow you to meet your long-term input rates, which can be complex and result in you over-provisioning. With Kinesis, when we want to scale, we can either do that manually, or we can run an elastic beanstalk-based auto-scaling daemon, which is cited at the bottom there. And the way that Kinesis works is that you split and merge shards together. And a shard is always available until it hits the 24-hour retention period. So in this case, if we took shards 1 and 2, and we wanted to create additional capacity, we would split shard 2 in half, and that would give us double the capacity, or 1,000 writes per second on each. And then when we want to go back to 2 shards, we would merge shards 2 and 3 back together. And that's something that can be done automatically. The last point about Kinesis that makes a big difference is the cost. Kinesis is designed to be extremely cost-effective so that you can focus on the consumer applications that you're writing and not on the infrastructure used to move data around. You can start as small as a single shard, which gives you 1,000 TPS, and then add and remove, and shards cost you 1.5 cents per hour. If we compare that to something that you're going to have to do yourself, you're going to build EC2 instances, and you need to size those. They probably need quite a lot of RAM. We're going to run a multi-AZ configuration, so we can't just run one broker. We need multiple brokers. We're going to use auto-scaling. And then you also need to invest the time to instrument where your consumer applications are in the stream using maybe something like CloudWatch in order to understand how your application is performing. And we get all of that for free with Kinesis, so it's just work you don't need to do. Also really pleased, along with the 1 megabyte size increase, we also did a price cut. We dropped the price on the 2nd of June, so this is fairly new news, and specifically we restructured the pricing model to be able to support the KPL better. It used to be that we charged you 2.8 cents for every million records you pushed onto Kinesis, but now when you're running the KPL with the aggregation feature, we're going to make much better use of that 1 meg of data. And so we've changed the pricing model to now be what we call payload units, or 25K blocks of data. And we dropped the price in half to 1.4 cents for every million payload units. Payload units are admittedly a little bit difficult to imagine, so I've given you an example of 50,000 TPS running at 50,000 TPS for an entire month. The old price would have been $678, and now with KPL-based aggregation on a 512 byte event, it will cost us only $300. So it's about a 50% price reduction for an infrastructure that will scale up and down as needed. Now, there are a few application best practices that I wanted to talk about, keeping in mind the mantra of Dr. Vogels, our CTO, which is everything fails all the time. And when you see services like DynamoDB, S3, Kinesis, we have built them with this mantra in mind. When you operate a system at the scale of something like Kinesis, there are machines failing all the time. The storage infrastructure is failing all the time, and we have to be prepared to operate in that sort of environment. So how can we help you build systems on Kinesis that will allow you to work with this constraint that everything fails all the time? And the first one is that we do really need to tolerate the failure of components within our consumer applications. This could be because somebody puts on a bad event, it's not formatted properly, and your logic just wasn't set up to deal with that, and so it crashes. There should be no human task involved in restarting that process. But it also might be that we add and remove threads just because we're scaling up and down. And so when we use auto-scaling for our consumer applications, or we use Lambda, we're going to have a very dynamic environment where we need to be able to tolerate individual failures. So one of the most important mantras, which I'm going to decompose a little bit later, is the fact that we really don't recommend that you store data locally. Your workers need to be seen as transient, stateless assets that perform a function and can be restarted at any time. Also, absolutely recommend that you take advantage of platforms like Lambda or Elastic Beanstalk to host your consumer applications. Why Elastic Beanstalk? Well, it gives us multi-availability zones for free. It allows us to scale up and down very easily. And it allows us to manage application versions with virtually no effort. We simply upload a new version of our consumer logic, we make it live, and Beanstalk handles rolling out that code base onto our consumer fleet. And KCL is very nicely able to deal with that sort of model by allowing a worker to be killed and then restarted on the old code, on the new code base that you've just installed. And lastly, we have to keep in mind that the best sort of infrastructure is the one that you don't have to manage at all. So taking advantage of Lambda means there are no servers for you to ever have to worry about restarting or scaling up and down. We simply run the required number of Lambda containers to meet your event volume. So on the point of application state, a very common pattern that we see customers struggling with is that they will bind a consumer to a fixed number of partitions. And they'll use that fixed mapping to do things like maintaining a database on a node. And then they'll create a read API that's able to go and requery that application by looking at the local storage of those systems and federating the request. And unfortunately, everything fails all the time, so we get into a situation where one of these has fallen over, and we have to consider how we recover that event data in order for our consumers to carry on, in order to deal with accommodating that read load. So what we do is we replace that instance using something like auto-scaling, and then in order to rebuild that application state, we have to read from the beginning of the stream for all time on those partitions that we were responsible for. And this model is extremely difficult to work with and actually results in quite a long startup time and means that you have to write all of the orchestration to make sure that this recovery works well. Instead, we need to externalize the state for our consumer applications so that they can be completely transient. So for example, if we can use a tool like DynamoDB, which is also regional, highly available, highly durable service, then we can blow away our consumers at any time and our database is still viable. There's no need to ever have to replay a stream to recover that database. And then lastly, of course, just to reiterate the point, if we use Lambda, there's nothing to fail at all. We guarantee that a Lambda function will be invoked for a payload of data on Kinesis. Where that is may be anywhere within the fleet of machines that makes up Lambda. The other pattern that's extremely important to consider is the need for item potency. And item potency is the property of a system that allows us to reprocess the same input events and end up with the same end application state. And can also be summed up as saying that we get exactly once processing semantics. It doesn't matter if an event gets repeated, we say, yeah, we've seen that. So what does this actually mean in practice, and how does it relate to Kinesis? Well, because of the fact that Kinesis is a distributed system running across multiple availability zones, it is possible that in some certain conditions, the client that you're using to push data into Kinesis may retry an event. For instance, they correctly write to one storage node, they get an acknowledgement from another storage node, but then they get a failure. And the client interprets that as a redirect and will retry that event. And this is just something that's built into our SDK. We handle a lot of retry events automatically so that you don't have to worry about them. And Kinesis producers are no different. And in this case, what we could end up with is two of the exact same event on Kinesis, but with different sequence numbers. And that's difficult for customers to deal with, and it's something that you absolutely must consider. And we've heard that feedback loud and clear, so we're going to do something about it. So in the coming months, we're going to build something called producer-managed item potency. The way this will work is that Kinesis will maintain a sized window in DynamoDB with which it will do automatic item potency checking if you so choose to turn on the feature. Then, if we do a write from the producer, and that record is made durable, but for some reason we were to end up sending back an error code to the client, we now know the request ID from your data that makes that unique. The way that you interact with this is you tell us, you give us a class within the producer library that tells us how to find the ID in your message. That's all you have to do. We will do this automatically. And then when the retry happens, which absolutely needs to continue happening, we get this condition check failed exception from DynamoDB. We know that your record has now been made durable, but we saw that there was an error before. And so we won't restore that message, but we will acknowledge it with an OK, which will allow for much, much more simple to manage item potently processed applications where we're doing a lot of the hard work to dedupe on the front end. So to wrap up, Kinesis really offers us a system that is much easier to manage than having to build it yourself. We get extremely high performance, up to terabytes per hour, with low latency on the order of 50 milliseconds to about 200. And crucially, the durability of that data is always multi-AZ. This data is your crown jewels, and so you need to protect it. We get extremely elastic performance at a very low cost so that you can focus on hosting the logic in the most appropriate place for you, and you can focus on building that logic rather than paying for managing big, hard, and complex infrastructure. And we can take advantage of a really nice ecosystem of tools that allow us to do things like making the stream 11 nines durable on S3, we can process it with Spark, and we can build applications with the KPL and Lambda. So with that, I'll say thanks for your attention today. Enjoy building applications with Kinesis and Lambda, and we'll be around to answer any questions that anybody has after the talk. Thank you.